Hello and welcome. Today's video is going to be a little bit different in that we're going to be talking about 3D printers, specifically upgrading 3D printers, or depending on how things go, how to break 3D printers. This right here is my Sidewinder Artillery X1 3D printer. It's what's known as an FDM printer, meaning it takes spools of plastic like this, pushes it through this device here, which just heats it up, pushes it through, and you get hot plastic comes out the end here. So the size of this thing is about 300 millimeters by 300 millimeters this direction, and then about 400 millimeters high. So that's the size of anything I can print with this. All in all, I'm looking to implement 5 new, we'll call them upgrades for now, depending on how it goes, probably downgrade. Anyway, so the 5 upgrades we're looking to do are replacing the build plate with a removable build plate. Don't know if you can see here, it's kind of difficult to manipulate with one hand. But you see this plate is removable, which makes taking parts off the plate much easier. I'll get into that in a second. I'm also looking to change the extruder setup so that the extruder can be removable. That'll allow me to try put different tools and stuff on the 3D printer, give it a bit more flexibility in that sense. I want to, specifically for the extruder, I want to add in a metal gear set. Currently there's a plastic one, which I want to try to upgrade that to metal. This is what's known as a BL Touch. This is used to kind of level the bed, make sure you're printing on a flat surface. The BL Touch I currently use has gotten a little bit damaged, so I'm going to replace that. And then lastly, this is a little control box, one of the first things I actually 3D printed. That just controls the 3D printer over Wi-Fi, makes things a little bit easier, but I want to try upgrade that and try fix it up a little bit. So, all in all, there's 2 fairly significant upgrades. It's going to require quite a bit of changes to the 3D printer, and 3 which are kind of more minor changes, they don't really need to happen. But anyway. So the focus of this video is going to be solely on the build plate here. Now, why are we not doing everything at once? Well, the reason is this printer has one of the, I suppose, very good things about it, but also one of the big downsides to it is this printer is wired using these ribbon cables. Now, while these ribbon cables look very sleek and everything kind of fits very neatly into one another, one of the big downsides to them is that if you want to add anything that's not already existing on the 3D printer that requires electronics and wiring, it gets very complicated because of these ribbon cables. Prime example is I tried to add this BL Touch at one point, and you can see I had to try glue and tape wires in sync with this, and it was a whole ordeal and actually ended up breaking the printer for a while. So because the tool changer is going to require swapping out this entire extruder and reworking all of this, that's going to require rewiring everything here. So there's no point starting that until we figure out how I'm going to rewire everything so that we can use this tool changer. So for that reason, we're just going to focus on the build plate here today. So how is this build plate going to be swapped out? Well, this is what's going to be coming into it. So this is the flexible build plate. As you can see here, this removes like that, and that just means that if you have your part printed on here and it's kind of stuck on quite tight, you can use the flexibility of this to pop it off quite easily. So this build plate has the sticky pads in the back here. So normally what you would do is you would take that off and you would stick it on there, and job done. For those of you at home thinking, all right, this will be a quick, straightforward video, sorry to disappoint. We're going to make a few more changes to this because this printer also has another issue with its build plate. So, I don't know if you can tell here, but there's these little dials you rotate underneath there, and that allows you to lower or raise each corner of the bed. The reason being is you want a flat bed, and sometimes these things can kind of have a bit of a warp in them somehow. However, there's one major issue with the mechanism, and that is these build plates, these adjustable knobs, create cold spots in your in your hot plate. So the way this works is this plate heats up so that when you put your hot plastic on here, it doesn't cool and contract straight away and detach from the plate. So in an ideal world, you want an evenly heated plate all the way around here for the first couple layers or for the entire print, depending on what plastic you're using. And you want that to cool very gradually so that when the plastic cools and contracts, it doesn't snap off and you lose your print midway through. One of the big issues this has had is right around here, because of this adjusting mechanism, there's a very poor heat around here, and glass doesn't conduct heat particularly well. So whenever I make a print that maybe starts here that's quite wide, oftentimes if it comes over this area, the print will detach here. So I'll end up having this kind of warped part around here. And it's gotten so bad that I've had to design parts that either kind of fit in this kind of plus shape there, which isn't ideal. So just to show what I mean here, what we're going to do is turn on the 3D printer. Here we go. The red flashing light means it's actually broken, so that's fix that another time. But anyway, one thing at a time. So we go to heat, and if we try and heat the bed, let's say to 60 degrees Celsius, what you'd like to see in an ideal world is 60 degrees all throughout the bed. And to test it out, I have this cheap temperature gauge there. So once this heats up, we'll come back here and I'll show you what the temperature is. Okay, so I've given it about a minute to get up to temperature. So the bed says it's reading 60 degrees. Now this isn't the most accurate scanner, but should give you a rough idea. And it's been sitting there for about a minute, so it's had a good time for things to heat up. So let's see if I can capture this. If we look at the edge there, shall we say, that's reading about 54 degrees Celsius. Whereas if I look right there, you see we're down to 39 degrees Celsius. I don't know if I'm catching that there. But you can see there's quite a big temperature difference between the across the plate. Even in the center there, it's a little bit lower. So 60 degrees is a fairly common temperature to set your bed to, but occasionally you do use higher temperatures such as 80 degrees Celsius there. So again, let's just see what it's like at this temperature. Yeah, you can see we're up around 70, yeah, it's reading about 70 degrees Celsius. Whereas if I move it up to one of those spots, we're down at 49, 48 degrees Celsius. Yeah, as you can see, it's not quite an even temperature distribution. Again, this isn't the most accurate reading, but even if I'm just to touch it with hand, you can see that's very hot. Whereas over there, I can fairly comfortably leave my hand without it getting burnt. This right here is a plate of copper. Copper is a fantastic conductor of heat. I.e., if I heat one part of the copper here, the heat will travel very quickly across here. Copper is great at spreading out heat. Now, in an ideal world, what I want to do is replace this entire glass sheet with a sheet of copper. Unfortunately, copper is very expensive, and I need this for something else. So instead, we're going to go with aluminium. So first step to replacing this bed is we're just going to unscrew these attachments here. Those are not so easy, so we have all four edges. This will allow us to take off the bed as such. We can remove the heated bed very carefully. And here you can see the underside. Alright, so this is the first time I'm actually looking at this myself. So, as you can see here, we seem to have 4 screws attached to the plate, as you'd imagine. So, next up what I'm going to do is I'm going to heat up the bed, and when the bed's hot, I'm going to try and remove the this foam underneath. That way I mightn't tear it, because that's my big fear now, is if I try pull this up now when it's hot, sorry, when it's cold, I mightn't actually get anywhere. But the goal is going to be to see how these are attached and see whether we can remove these and place them on our metal sheet, which we're going to be making next. Okay, so what I've done is I've set the bed temperature quite high, and here you can see it's starting to heat up quite a bit. Now I have this paint scraper, and what I'm going to try do is use this to pry underneath the bed like that, and try gently pull it up without causing any damage. I'll wait for this and just camera to the side as I'm using my hands this way. Okay, so an update so far. So I've made a bit of progress peeling this off. I've decided to turn off the heater, as now it's starting to get a little bit too, as I start to get deeper into it, it gets quite hot and hard to handle. So I've turned off the heater as well. I'm a little bit conscious this heating is like a mains voltage, mains powered heater, so it can get, I suppose, a little bit of a risk in case of nick a wire or something like that. So I've disconnected the printer there. And so I'm just going to keep pulling this up gently, but as far as I can tell, there is these pads here, which is great news, because it means I can just remove those pads and just make sure I note exactly where the positions of these are, and then when I make up my metal plate, I'll be able to place these pads exactly where they are currently on this plate on the new plate, and that'll hopefully make things a bit easier. Okay, that was quite the battle, but slowly but surely I managed to kind of pry up one corner and slightly pry up the other, etc, etc. Didn't make for very exciting video footage, so I just skipped that. You can see the end result here. Here's the heat map itself, the heated bed. There's still, I think, enough stick on that it should be able to go, the aluminium sheet should be able to go on that pretty handily enough. But this is the actual metal plate. As you can see, I'm going to have to figure out, what I'm going to do next is measure the distances from the edges that these are. And then I have to figure out how to take these off next. Now, these look to be a bit more complicated to get off because, yeah, they look like they're epoxied pretty tightly on there. Yeah, I'm going to try to figure out how to get those off. I still think the easiest way forward would be to take these off and just place them on an aluminium sheet, but anyway, we'll get there when we get there. That's definitely next steps. So, it's the next day and I've had a little bit of time to sleep it over and think about what the next steps are for this. So I've decided, so I measured up the build plate, and actually it's 31 centimeters by 31 centimeters, so a little bit larger than the 300 millimeters advertised, which is great. So I'm about to head out now and cut the aluminium sheet to this size. Now I was thinking about how we could make it so that the aluminium sheets themselves are removable, so you have kind of a quick change aluminium sheet on which your different build surfaces can go. And what I've decided is I'm going to elongate the sheet in one direction by 1 centimeter on either side. And what that'll do is that'll allow me to use this section as normal. And then I'll have this extra bit here, into which I'm going to drill 4 holes. And those 4 holes will allow me to place another sheet of the same size on top of it, screw it down, lock it nice and tight. That way I'll be able to change out the sheet, so I'll be able to still use this glass sheet without having to do any major changes for it. And the other advantage I'm thinking that might happen is, you'll see in a second, the sheets of aluminium I'm going to use are thinnish, they're not that thick, So having two sheets on top of one another, that might, I suppose, increase or decrease the chances of it warping. So next up, we're going to head outside and we're going to actually start cutting up the aluminium, and I'll show you my process for doing that. Okay, so here I'm at my parents' house, setting up their table saw. So this is the glass plate. I've kind of measured used this as a reference for the width we're looking to get. So we place the metal here, and it'll be getting cut against this, so we have a nice exact length there. So this is the sheet of aluminium we'll be using. It's not overly thick, it's a fairly thin sheet, so you can use that like thin aluminium on a wood cutting table saw. There's no real issue there, you just have to go slowly while cutting. And yeah, so I've measured out roughly what we'll be cutting, so you can see here 31 centimeters is the width of this. And because we want to add an extra centimeter on each side, these notches here are 33 centimeters from the top there. So again, this is just a rough idea to make sure we have enough material. So all the way down here, this is the 99 centimeters. Now we'll be needing a little bit more because likely the width of the blade there is going to be taking away material, but it's not an exact science. We're just looking for a little bit more to allow us to drill. So next up, I'm going to get the table set up. Well, i.e. load the metal onto it, and then start cutting. I'll see if I can get some videos of that. The only thing is I need both hands for this, so it's very much we'll see how we go. Alright, so what I've done is I've widened this to about 33 centimeters. I actually cut off the edge with this bit here because there was a kind of a bad corner. So you see it's more or less lining up. I think with that edge cut off, that's about 33 centimeters. Again, it doesn't need to be exact, it just needs to be the same across it. So I'm going to cut this into 3 sections here, and then yeah, that'll be the plates made. Okay, so here you can see the original plate with the newer plate cut underneath it. So you can see lengthwise here we're perfect, and we have a little bit sticking out on either edge, which is exactly what we wanted. Looking at this here, it's about a centimeter. Let's check that there. Yeah, it's about a centimeter, maybe a little bit less, either side of that. Now, I'm sort of wondering whether I should even add a little bit more there, because we have a bit more material. I just don't want to make this too large. This should be small enough that I'll be able to drill this out without any real issues, so I think we'll probably leave it at that. But yeah, so far so good. Okay, so what we're going to do now is we're going to try to see if we can remove these pillars. So my best guess is that there's sort of epoxy or something underneath there. So just reading online, I found that acetone is actually apparently quite good at breaking down epoxies. So what I'm going to do is I've made a little well here with blue tack, and what I'm going to do is I'm going to pour some acetone in here and let that sit for 15-20 minutes. Just down. Okay, so again, quite strong stuff, so you want to be very careful. You want enough. There's a little well, essentially. A little drop more. Right, I don't add more than that. Okay, so quick update. We tried the acetone for about 20-25 minutes until essentially all the acetone evaporated. But while it did erode away some of the what do you call it, some of the glue, it couldn't penetrate it to actually get the majority of it. So decided then to try give the heat gun a go, and that seemed to work really well. So I'm going to give another go and try to get the last 3 of these sections up. Essentially what I was doing was heating that area in particular, but also trying to spread out the heat so that we don't have a huge heat difference, because even though this is a bed used, even though this is a heated bed, I'm still a little bit wary of the glass cracking if there's too much of a heat difference. Okay, so I did a rough fitting here, nothing's been glued in. I just put some blue tack on the 4 posts under there, just to make sure the positions I had them in actually worked. And so far so good, looks like it fits in pretty well. Okay, so I've reattached the hotbed to the metal plate there, essentially to get the glue nice and sticky. I just heated up the hot plate, kind of like made all the leftover glue there still quite sticky, but I also added a bit of thermal adhesive just to be on the safe side, to maybe help the heat transfer a little bit. So now, the moment of truth. I get to peel off all of this. There we go. Ooh, that looks good. Very happy with that so far. Okay, so I've lined up the plates, I've kept them in place with these just loose grub screws there. Plan is eventually they'll kind of come in from the bottom, I'd say, like that. That might be the neatest way, but anyway, that's still to be decided. Now, I just need to line this up such that I get as much space as possible at the back. Here we go. So yeah, definitely didn't leave enough space at the front here for these for the mounting points for this particular plate. I think it's not a big deal to just drill in another hole there, which I probably will do at some point, but for now, it'll do. Okay, so we've heated up, and so far so good, nothing's exploded. I have noticed, I think it takes a little bit longer for the heat to properly get onto this pad. I think that's likely due to the fact that it has to travel through 1, 2, 3, 4 layers of material to actually get up here. Also, I'm not sure how well a conductor this heated bed is. But anyway, one of the interesting things is, so I heated up to 80 degrees, and I'm now letting it, turned it off. It seems a bit slow to come down, which would make sense. If it's slow to get hot, it's probably slow to cool down. But you can see here in the corner, we're at about 55, 54 degrees. Go towards there, 57. So there is a bit of a temperature difference, but it is notably smaller than what we had before. We're looking at about a 2-degree difference, really, between the hottest part of the bed, the center, and the corner, which is the coldest part. Okay, so just to, I suppose, wrap everything up. Done a few prints on this since installing it, and works really well. It does take a while for the heat to get to the top of the mat. I guess that's because there's now essentially 1, 2, 3 layers beneath the heater, beneath the mat, and the actual heated bed. So just have to bear in mind it takes a bit longer for the plate to get up to get the temperature, but it's nothing that dramatic. Haven't stuck the glass plate on. Probably not going to put this video. Probably going to put this video out anyway, just because it's taken ages for me to actually do it. I'll probably just get some more thermal adhesive like this and stick it onto it. I'm debating that, or just getting glue. That's not really a major thing. This is kind of the main change I wanted for now. That was more of a nice to have. So yeah, all in all, pretty happy. There's still some improvements needed on this, so you can see the holes I drilled in here just aren't great. I can't really get a screw in it. So I'm going to have to re-drill these. That's not a major hassle. I'm trying to think what else. Yeah, the other thing I would be nice to do is actually seal off, put some insulation around the sides here, because you can see there's quite a bit of metal exposed that's kind of just wasting heat unnecessarily. I'd like to kind of get those covered up, get the, just I suppose, improve efficiency a little bit. Yeah, that's really it. Like I said, that's why I need to get the screws in here, because this top bit is kind of coming loose. But aside from that, everything is pretty good. So that's the first major, I suppose, upgrade done on this. The next thing will be, I suppose, ironing off the last few bits and pieces here. We'll cross that bridge when we get to it. For now, though, thanks very much for watching, and hope you enjoyed it.